Hello class. This week we are studying Chapter 7, Demand Management. I'm going to outline each of the learning objectives this week, and I want you to think about them and apply them as you read and study. The first objective of this week's chapter is to understand the critical importance of outbound to customer logistics systems, appreciate the growing need for effective demand management as part of an organization's overall logistics and supply chain expertise, know the types of forecasts that might be needed, and understand how collaboration among trading partners will help the overall forecasting and demand management processes, understand the basic principles underlying the sales and operations planning process, and identify key steps in the order fulfillment process. Appreciate the various channel structures that might be used in that fulfillment process. So I want to talk a little bit about the outbound to customer logistics systems and the comparison between that and the inbound to operations logistics systems. So first of all, with our outbound to customer logistics systems, that's referred to as our physical distribution. That refers to your processes, to your systems, and your capabilities that enhance an organization's ability to serve its customers. The topic of inbound to operations logistics systems refers to the activities and processes that precede and facilitate value-adding activities such as procurement, manufacturing, and assembly. And if you remember back to our lectures in Introduction to Supply Chain Management course, you will understand what the value-added means and why it's so significant. When we talk about demand management itself, the book likes to define it as your focused efforts to estimate and manage customer demand with the intention of using this information to shape operating decisions. But traditionally, supply chains begin at the point of manufacturing or the assembly line, and then they end with the sale of the product to the consumers and the business buyers. But the whole essence of demand management is this: it furthers the ability of our firms throughout our supply chain. Most importantly, it's those manufacturing firms through the customer to collaborate on activities related to the flow of your product, your flow of services, as well as information and your capital. So that is something that you need to think about in that respect. And demand management also seeks to satisfy customers and solve customers' problems. And some of those is like they do this by gathering and analyzing knowledge about customers, their problems, and their unmet needs. They also do things such as share with other supply chain members knowledge about customers and customers' available technology, their needs, their wants, their likes, their limitations. Identify partners that perform functions needed in the demand chain, and also develop and execute the best logistics, transportation, and distribution methods to deliver products and services to customers in that desired format. And that data from demand is used strategically to enhance the growth of the organization, its portfolio, its position, and its investment strategies. And when you do that, it's an effective use of that demand data that helps organizations and guides them to the strategic resources that they need to be able to do business. When we talk about balancing supply and demand, we look at this. The essence of demand management is pretty much to estimate and manage customer demand and use that information to make operating decisions. And there's about four different methods that's used across the industries. And the two of those, the price and your lead time, those are external balancing methods. That's on the outside. And the other two are your inventory and production flexibility. And those are internal. So that's really a no-brainer. You know what goes on the outside, what goes on the inside. And when you think about these external balancing methods, I want y'all to think about this. What the whole motivation is to help to change the manner in which customer orders, and it's an attempt to balance the supply-demand gap, okay? So that's pretty much straightforward. And then we talk about the internal balancing methods. They utilize what the organization already has in place, its processes, its functions. And that also helps manage the supply-demand gap. When we think about production flexibility, that also allows our organization to quickly and efficiently change its production lines. And there is a trade-off, though, and that trade-off is between production and the changeover cost, and of course safety stock costs. So we already learned about safety stock, and we understand that's important from the Introduction to Supply Chain course. And inventory is also the most common, and it must be the most expensive. When I say maybe, I don't think there's a maybe there. It is your most expensive commodity. And it is an expensive method that's used to manage the imbalance between your supply and your demand. And there's a lot of organizations that produce product to a forecast that includes safety stock. So when you think about that, it's to smooth over those effects that both demand and lead time can cause variabilities in. So that's going to lead us into why forecasting is so important, okay? So when we look at the traditional forecasting methods that supply chain professionals use, it's a major component of demand management. And we have to forecast the amount of product that will be purchased. We also need to think about when it will be purchased, where it will be purchased from by the customers, okay? Which retail establishment, which distributor will they get that from? Now, there's various statistical techniques that you can use and that exist in how to forecast demand data, but there's a common thread for all forecasts is that they will all ultimately be wrong. And as I said that, you're probably looking at the screen like, what? But that's the truth. So let me go a little further. So it all has to do with the factors that affect demand. So there's two types of demand that exist. We have our independent and dependent demand. This is probably very familiar to you if you've taken Mr. Cook's Introduction to Business class or Mr. Lim's Intro to Business course. You are probably very familiar with this. The independent demand is a demand for the primary item, and dependent demand is directly influenced by the demand for the independent item. And the demand is for the independent demand items is known as base demand and also normal demand. And normally, the demand for independent demand items is also known as the base demand, and all demand is subject to certain fluctuations. And a second type of demand fluctuation is caused by a trend, okay? The first one was caused by random variation. And when a trend is a gradual decrease or increase in demand over time in an organization. And the third type of demand fluctuation is caused by seasonal patterns. And the seasonal patterns, they usually repeat themselves during a year for most organizations. And demand fluctuations can be caused by just your normal business cycles. Sometimes business is good, sometimes it's not. Now, there is the simple moving average, and of course, it's a very simple calculation. But I'm going to explain as you look in Chapter 7 of your book what the simple moving average is. And as we look at that, the simple moving average is pretty much defined as the simplest way to develop a method in basic time series forecasting. And what it does is it helps your forecast on recent demand history. So as we look at that, the simple moving average method does not accommodate seasonal trend or business cycle influences. All right, so when we look at that, there's just a very, very simple formula in Chapter 7 that is outlined for you. And as we look at that, I do want you to take a look in your book very carefully as we talk about forecasting. And on page 222 and 223 of your book, there is a simple moving average, and then there is actually the example formula on 223. And so what it starts out is AT is equal to the sum of last n demands divided by n equals d plus t minus 1 plus dt minus 2 plus dt minus n. So what it's actually doing is the formula is actually telling you is your actual demand period t is equal to the total number of periods in the average, and then it's divided by the average for period t. When you actually add together those error terms for the forecast results in what can be called bias. Bias measures how accurate that the forecast is compared to actual demand. And the positive bias means that the demand was higher than the forecast. You're not actually going to be forecasting these formulas in this course. You're just going to be seeing these examples. And if you look on page 223, there is the example of that forecasting and how that can be. There is a little example problem on 223 that you can actually you can look at and see how they calculate that, but it's not an actual problem that you have to work out. All right, after we add together those error terms for the forecast, it can be called bias. We talked about that. The bias measures how accurate the forecast is compared to actual demand, and then your positive bias means that demand was higher than the forecast during the forecast period, and that actually results in stockouts, which is a negative bias, and that means demand was lower than the forecast, and that results in excess inventories. And when we think about that, the closer the bias terms is, the better the forecast. The weighted moving average is our next one, and as you look on page 224 in your textbook, there's an example of that particular formula in there as well. And there's also outlined for you in our lecture PowerPoint for this week's module as well. And so the weighted moving average is just a simple moving average. Each previous demand period was given an equal weight. The weighted moving average method assigns a weight to each previous period with higher weights. That's usually given to more recent demand. And that formula is also given to you in your book. And we look at the exponential smoothing, and that's also one of the most commonly used techniques because it's very simple. What it does is it limits the requirements for your data, and it needs 3 types of data. It has to have your average previous demand, the most recent demand, and a smoothing constant. And the smoothing constant must be between 0 and 1. And using a higher constant assumes the most recent demand is a better predictor of future demand. When we talk about that, we can also talk about adjusting those exponential smoothings for trends that we see that appear. And also there's also seasonal influences on those forecasts. And sometimes it can be by time of day, on seasons. For example, it could be the demand for hamburgers at a fast food outlet, or by the day of the week, like the demand for gasoline, or by the month, or by some combination of all those factors. So when we talked about forecasting and how it's supposed to be wrong, you may again be still wondering about that, but forecast errors, almost all your forecasts are going to be wrong, okay? And some of the forecasts will be higher than demand, some will be lower, but managing those forecasting process, that requires minimizing the errors that's between the actual demand and the forecasted demand. So that key is successful in forecasting is to choose a technique that provides the least amount of forecast error, okay? And to determine which forecasting technique is best for a set of data, the forecast error must be measured. And as you're looking at forecast errors, over on page 229, 230 of your book shows you some examples as well as how those are calculated. When you go out into the field, you will be working with enterprise software that will mostly do those calculations for you. But what I want you to do is to be able to see them and work them by hand, or see how they are worked out by hand. And that's how you will work. You will learn that. When we talk about sales and operations planning, many organizations have developed several functional forecasts for the same products during the same period of time, such as your financial forecast. And we look at what they call the SOP, and that's called the Sales and Operations Planning. An SOP and Benchmarking Consortium is a Center for Supply Chain Research adopted the 5-step process. And there's a 5-step S&OP process. Now, when we talk about collaborative planning, forecasting, and replenishment, there's many industry initiatives that have attempted to create the efficiency and effectiveness through the integration of our supply chain. We talk about quick response, QR. We talk about vendor managed inventory, which is VMI, continuous replenishment planning, CRP, and efficient consumer response, ECR. And then we've got good old CPFR, and that's the most recent initiative. And what happens is it is collaborative planning, forecasting, and replenishment, CPFR. And CPFR has become recognized as a breakthrough business model, and it's for planning, forecasting, and replenishment. Retailers that use this approach, and distributors and manufacturers, they utilize the available internet-based technologies. It helps them collaborate on operational planning through execution, and transportation providers have now been included with that concept. The CPFR process is pretty much begins with the sharing of marketing plans between trading partners, and once an agreement is reached between those two partners on the timing and planned sales of specific products and the commitments made, then the plan is used to create the forecast, and then also by a stock keeping unit called a SKU, and that's by week and by quantity. And an accurate CPFR forecast can be translated directly into a production and replenishment schedule. And so this will allow the manufacturer to go in and make the products to order based on the quantity and timing of demand. And then we're going to look at the fulfillment models. And those are we look at our channels of distributions, and that's when one or more of our organizations of individuals who participate in the flow of goods and services. The channel of distribution can also be thought of as the physical structures and the intermediaries between those flows of travel. And they can encompass a variety of intermediary firms, and they can be classified as distributors, wholesalers, retailers, transportation providers, brokers. The logistics channel is very long and very encompassing. We've got the logistics channel. It refers to the means by which the products flow physically from and where they're available. And effective channel management requires a good grasp of the different alternatives that are available to deliver a product. And then we've got the DTC fulfillment, and that's our direct to customer. And when we talk about that, integrated fulfillment is many retailers in today's business world. They have to maintain both a brick and mortar, and they also have a clicks and mortar, which is the online version, presence to the consumer. And they have to have both of those retail stores as well as the internet sites to help them stay in business. And dedicated fulfillment is pretty much the same, sees the same delivery goals as integrated fulfillment, and it has two separate distribution networks. You have your outsourced fulfillment, and that turns over the fulfillment to responsibilities to a third party. And then also a drop ship fulfillment, and that manufacturer delivers its products directly to the retailers. And then you got your store fulfillment, and those are for a retailer that has both the storefront as well as internet presence, and there might be some reduced control. And then the flow through talks about the main difference between the flow through and the store fulfillment, in that the product is picked up and packed in the retail distribution center, and it's sent to the store for the customer pickup. So those are some major functions of demand management, some things I want you to think about as you study this week's chapter. Please be sure that you will go through all the resources that I have in the Week 7 module folder. There are YouTube videos with explanations on how to compute the weighted average, a simple moving average. Although there's not really any homework in that respect, I still want you to practice those. So when you enter inventory class, you will be aware of what those formulas are and how they can help you with those inventory problems that will work in that class in our spring semester. So again, that is chapter 7, and I hope you have a great week.